Welcome to Mastering Solutions. I've already drawn the picture of what's happening in the question, so you can use a normal arrow to represent a converging lens. You can use an arrow that is backwards, where the arrow goes out like this to illustrate a diverging lens. And so these are the two focal points. I try to draw them as equally distanced from the lens as I could. In this question, they say to use ray tracing to figure out where the image is at. And if we drew this to scale, like if we had it on graph paper and drew it really, really precisely, you could actually get a very accurate answer of where the image will form. We're not going to worry about that here. We're just going to show you how to do the ray tracing. And then I'll also show you how you can calculate with the thin lens formula to figure out where it's going to be in case they want you to actually give an answer of where the image is going to form. So there's 3 steps to do any ray tracing. Just remember, parallel to the focal point, and then center of lens, and then focal point to parallel. If you remember this, say it over and over and over, so when you get on the test, you can repeat it. If you remember that, you can do any ray tracing. And so what we're going to do is we're going to start from the object here, and we're going to draw a parallel line parallel to the horizon here. And then when we get to the lens, since this is a converging lens, it's going to go straight through the focal point, and then it goes off like that. Now we're going to have one from the top here that goes straight through the center of the lens. And so the reason we're doing 3 is you could draw an infinite number of rays coming off the top of any object or any point on any object. And so in order to find the minimum necessary to get an image, these are the 3 here that we're going to draw. And then the last one, what we're going to do is we're going to draw it straight through the center of the focal point. Only once we hit the lens, then it's going to go parallel. So you can see where the rays converge is outside of the focal point right here. And so since it's a converging lens, we will have a real image. So it'll be real and it will be inverted. And so this is the ray tracing. Now let's figure it out with the thin lens formula in case they want a precise answer on where it's going to be. What it is 1 over f is equal to 1 over s plus 1 over s prime. We're trying to solve for s prime. So let's minus over 1 over s. So 1 over s prime is equal to 1 over f minus 1 over s. And so when we plug in our numbers here, we have 1 over the focal point, and that's 0.1 meters for the focal length of our lens. And it's a positive lens since it's converging. And then we're going to minus 1 over the object distance, which was 30 centimeters. And since it's on the front side of the lens over here, by convention, that will be a positive value. So that'll be 0.3 meters. And so we have 1 divided by 0.1 minus 1 divided by 0.3. And so that gives us 6.67 diopters. 6.67 diopters. But to get the distance here, we need to take the inverse of this, and that will give it to us in meters. So 1 divided by the answer gives us 0.15 meters or 15 centimeters. So our image distance is 15 centimeters away from the lens. It's real and it's inverted.